This video, we will continue our discussion of section 2.6, part 2, Bernoulli differential equation. So, we actually can see the Bernoulli differential equation here, pretty straightforward. We can see that it looks like a linear equation, except for this has a multiple of y squared there, which tells me n is 2. Now, what we actually do to set this up is we say, okay, we're going to let mu1, hold on, I keep messing up. Mu1 equal, very dramatic mu1, y to the 1 minus n. That is y1 minus 2, right? Which is y to the negative 1. Okay, so that is one thing we need to keep in mind. Purple's so dark. All right, mu1 is y to the negative 1. Okay, so we can also pick up d mu1 dx. So the negative 1 comes down, becomes a negative 2, then we get dy dx because we're doing it in terms of x. Okay, so we also have that. So let's do that in a different color. We'll do that in yellow. That's equal to that. And then remember, we multiply by this side. Multiply by that. So I'm taking my DE, I multiply by negative y to the negative 2. But it's not the whole thing. It's multiply by that without dy dx. We're not going to take that with us. So we're going to multiply that throughout my differential equation here. So that's, I'm multiplying right now by that. So I got negative, it's going to become a negative 4 over x. And we're multiplying by y to the negative 2. So this becomes y to the negative 1. And then the right-hand side, I'm multiplying by negative y, negative 2. So I get a negative x cubed because the 2's will make a 0. And we get y to 0, which is 1. So I just multiplied this by that. Okay. So let's see what we can replace now. So now we're trying to get things in terms of something else to make it a different type of an equation. So check it out. What's in yellow there? Those two things are the same. So I'm going to replace that, d mu1 dx minus 4 over x. I can replace y to the negative 1. That's actually mu1. And then the right-hand side, I just leave alone. Now, this equation is a first order linear DE. It's a first order linear DE. You can see it there. Mu1 is to the first power. So we need to set up an integrating factor. So we'll do that. We'll call it mu2. That's e to the expression in front of mu1, which is negative 4 over x dx. This becomes e to the negative 4 integral 1 over x dx. We're going to start seeing this a lot. So e to the negative 4 integral 1 over x is ln of x. We don't need to put plus c. This becomes e to the ln x to the negative 4. I can drop the absolute value because it's to the fourth power. And that is equal to x to the negative 4. All right, so let's highlight that. Whoa, I don't know what just happened there. There we go. This is equal to this mu2. Okay, so now we're going to multiply by that because remember we have the blue equation there is the first order linear DE. So I'm going to multiply that equation by mu2. So we have x to the negative 4 times d mu1 over dx minus, let's go ahead and just distribute that actually. Minus, okay, we're multiplying that, negative 4 over x to the 5th. We're multiplying by x to the negative 4 times mu1 equals, okay, and we get negative, here we got negative x to the negative 1. That's multiplying this by the x to the negative 4. All right, this is the product rule. You can check this out. You should double check it, right? So I have the integrating factor times mu1. That's our independent variable. Check the product rule. You should stop and check that. The right side doesn't change. We just have that. Right, now I take the integral of both sides. Right, and then we have the integral of, okay, I'm going to bring this negative out. It's 1 over x dx. That's what x to the negative 1 means. Right, so now we do our integral. We have x to the negative 4 times mu1 equals, okay, this becomes negative ln, and I'm just going to put x because at the beginning of the problem, if you look, it says x is greater than 0, plus c. Okay, we have now, we can replace that mu1. Actually, this was, yeah, we need to do that first. Okay, x to the negative 4. Mu1, let's scroll back up and take a look. Mu1 was y to the negative 1. So I got a y to the negative 1 equals negative ln x plus c. Now we're going to use our initial condition now. Using y of 2 equals negative 1, we're going to plug all that in here. 2 is x. Y is negative 1. And we're trying to solve for c. So we got negative ln of x, which was 2, plus c. Right? This all becomes on the left side. It's a 1 over 32 equals negative ln of 2 plus c. So that means c is ln of 2. We should put the 1/32 first. 1/32 plus ln of 2. Then it's clear that the 1/32 isn't into the ln. So that means my equation is x to the negative 4 times y to the negative 1 equals negative ln x plus 1 over 32 plus ln of 2. This is a great answer, right? We have all the dy, dx is out of the way. We have everything. We have gotten down. We could even solve for y if we wanted to. We could just flip everything, right, for the y equal to the negative 1 after we multiply by x to the 4th. We don't have to do that, though. We can take this implicit answer. Oh, great.